Under transport, we have the next one as high-speed rail. I think everybody knows it, and as soon as you say high-speed rail, the bullet train comes to mind, and Japan comes to mind, of course. The ranking of this solution is at number 66, 1.42 gigatons of reduced CO2 by 2050. And the net cost is high at $1.05 trillion, which is often used as an argument against it, but we'll see if it can be compared against other modes of transportation. The net savings are at $310.8 billion with lots of co-benefits that are not always so obviously accounted for. Here is the example of the Japanese Shinkansen bullet train. It's arriving at Tokyo Station on January 19, 2016. Japanese rolling stock manufacturers have been collaborating with the Japan Railways group to expand the business worldwide with its technology and standards used for the Shinkansen bullet train system, which started in the 1960s, I think, with the Tokyo Olympic in 1964. Texas Central Partners LLC plans to start construction of the Texas Central Railway high-speed rail project between Houston and Dallas next year using the Shinkansen bullet train technology. California has a huge interest in high-speed trains. The way California is running north to south, it makes perfect sense to have a beautiful shoreline line going high speed, connecting LA to San Francisco and San Francisco to other Silicon Valley cities, which are already connected but not with the high speed trains. Nonetheless, just briefly looking at the history here, I am always curious about when students are learning to do things and doing little projects for, let's say, climate solutions on food, water, energy, and health, they should think of these sorts of things. Here is from 1830, rocket locomotive by George Stephenson reaching 50 km per hour. This may sound ridiculous now, but at that time also people may not have seen it as a game changer. But little things that you try end up being game changers, like telegraph, for example, is now linked to everything from smartphones to space travel. So when you do a project, think forward, have fun, don't worry about the immediate payoff or application. 1903, Siemens and AEG electric car reaches 210 km per hour. 1964, 1st October, the Shinkansen first high-speed rail system starts in Japan. 1981, the TGV, the first European high-speed train, operates in France at 260 km per hour. 1988, 89, and so on. Now in 2018, high-speed train in Morocco and Saudi Arabia. You can see that this is now spreading around the world, and we'll see some tables where Asia and especially China is really dominating this business. This is from the International Energy Association, I hope, International Energy Association, IEA, I think. 1,000 line kilometer here, looking at light rail, metro, and then high-speed rail from 2000 to 2018, and you can see the increase here. International Energy Agency, sorry. This is from UCI.org report, high-speed rail network length in terms of kilometers, looking at total Asia, Europe, and others. So Asia dominates, mostly China, but India has plans as well. So also between 1980 to 2015 went from around less than 5,000 to now more than 50,000 kilometers. Modal shares, we look at air, rail, bus, and private cars or two wheels. High-speed rail is very efficient at journeys between 1 to 7 hours, I think few hundred kilometers in terms of the transit time between door to door. So this is looking at millions of journeys in numbers here, looking at 100 to 300 kilometer. Private cars and two-wheelers dominate. Rail has a good fraction here. Between 300 to 600 kilometers, the train increases. Obviously, the number of journeys drop as well, 600 to 1000 kilometer, and then the train again disappears and air travel becomes much more dominant, which is just an indication of how to plan for high-speed rail, or how to make the journey time less so that people opt as easily with high-speed rail as they do with air travel. People go to the airport hours before, go through security, wait there, and then spend much more time on the other end. So the first mile, last mile problems can be big in airports, and the space they take, the footprint, etc. is high as well. But nonetheless, psychologically, it feels like you made a quick travel, because the actual flight travel could be much shorter than the train, even though there is no sightseeing, which is a big advantage of trains, of course. This is just looking at length of lines in operation in kilometers, lines under construction, approved but not started construction, and maximum speed in kilometers per hour. China dominates in everything. Then comes Spain, Japan, France, Germany, Sweden, UK, South Korea, Italy, Turkey, Russia, and Finland. As we saw, even Saudi Arabia, India, and other countries are now on this path. Door-to-door travel times between downtown San Francisco and downtown LA by mode. So here is high-speed rail, 3 hour 10 minute. Transit Bay Transit Center to LA Union Station is added here just for fun. Airplane, on the other hand, you can see the number of hours. The transit time is much larger. This is at about 3 hours. This is at more than 5 hours in terms of the taxi, the security, the actual flight. On the other end, again, the road transport, especially including traffic and so on. So here, Transit Bay Transit Center makes a difference. Auto, of course, is much longer, but it has other attraction for people. Percentage of total project cost. There is a constant argument, as we said in the beginning, that the net cost for high-speed rail can be high, but when a life cycle kind of analysis end-to-end is done, the costs include land acquisition and resettlement, civil works, track laying, signaling, communication, electrification, and so on. So you can see that as the length of the or speed of the train increases, the costs can increase as well. So it depends on the marginal cost for addition of speed versus the cost. So overall, there has to be some calculation done. But you can look at it in terms of equivalent consumption and CO2 emission for a 600 kilometer trip by flight. It takes 43.1 liters per person, 93 kilograms of CO2. A car would take 31.5 liters and 67.4 kilogram of CO2, whereas high-speed train is down at 6 liters equivalent and 8.1 kilogram of CO2. So this is primary energy consumption and carbon dioxide emission. Almost all high-speed trains are basically run on electricity. So if electricity is produced with renewables, obviously it'll have a very low carbon footprint, as we expect. Average external cost is also compared here in terms of accidents, noise, air pollution, climate change, up and down stream process, others, and then total. And you can see that car is very high, air is quite high, and rail is the lowest in this kind of external cost calculation in terms of euros per 1,000 passenger kilometers. So all said and done, high-speed train makes a lot of sense in terms of investments for the future as a part of the drawdown. If HSR construction and ridership continue at their projected pace, This solution can deliver 1.5 gigatons of carbon dioxide emissions reduction by 2050, a global network of 64,000 miles of track with an average trip length of 186 miles could support 6 to 7 billion riders annually. 6 to 7 billion riders annually. So imagine how many million cars will be taken off the road and how many air travel miles will be reduced. Regionally, most impact will come from Asia, especially China. If HSR is concentrated between cities with heavy short-haul flight routes, impact can be greater, so you can optimize the network. Implementation comes at a steep cost of $1 trillion, as we said. Operational savings over 30 years, however, are at $368 billion and $1.3 trillion over a lifetime of high-speed rail infrastructure. So obviously not all external benefits or co-benefits are accounted for, but again, high-speed rail is part of the solution and it's a no-regret solution as well.